Hello guys, welcome to this ML Demystified video series. I'm Dr. Ganesh and we were seeing some of the algorithms used for machine learning process. So these are briefly the steps involved in a machine learning process, right from data gathering all the way to data visualization. And we were seeing some of the algorithms as examples for classification, regression, clustering. Today in this session we are going to I'm going to speak about perceptron, which is the basis of neural networks. So have you ever wondered how your brain recognizes numbers? No matter how the digits or numbers look like, brain will relate that to the best possible pattern and concludes the result, isn't it? This is where the thinking came to make a something which can recognize similar number patterns, and this is where neural network starts. So what is artificial neural network? A neural network is a system designed to operate like a human brain. Human information processing takes place through the interaction of many billions of neurons connected to each other, sending signals to other neurons. Similarly, a neural network is a network of artificial neurons as found in human brains. So, this is to solve artificial intelligence problems such as image identification, audio identification, and many others. In other words, artificial neural network is a parallel computational system consisting of many simple processing elements connected to perform a particular task. The biological motivation. In a human brain, the dendrites receive signals from other neurons, as you can see in this image. The cell body sums the incoming signals to generate input. When the sum reaches a threshold value, the neuron fires and that signal travels down the axon to other neurons. The amount of signal transmitted depending upon strength of the connections. Connections can be inhibitory, that is decreasing strength, or excite. In a similar manner, it was thought to make artificial interconnected neurons like biological neurons, making up an artificial neural network. Each biological neuron is capable of taking a number of inputs and produce output. So neurons in human brain are capable of making very complex decisions. So this means they run many parallel processes for a particular task. One motivation for ANN is that to work for a particular task identification through many parallel processes. How does a neural network looks like? The artificial neurons are also called as perceptrons. This consists of an input, the x1, x2, etc., a weight, w1, w2, etc., a bias, an activation function, and an output. All the inputs multiplies with their respective weights. So xi dot yi wi, and all these multiplied values are added. Some of these values are applied to an activation function and the result is decided. Now the input layer consists of inputs and weights as we discussed before, the xi wi. The hidden layer. In a neural network there can be more than one hidden layer, and hidden layer contains the summation and activation function, and the output layer consists of the result. Suppose you want to go to a food shop. Based on three factors you will decide whether to go or not. Say weather is good or not. X1 is weather. and you have a vehicle availability x2 and money x3. Based on the conditions, you choose weight. Maybe W1 is 6, W2, which means okay, here the order there's a small typo. So the money W3 is 6 and W2 is 2 and W3 is 2, so whatever, some threshold, and you say your total threshold is 5. So Perceptron makes a decision by doing x1 W1 plus x2 W2 plus x3 W3, and if that sum of sigma xi wi is above 5, then I will go for food outside. Now, activation functions are used to map non-linear complex wave functional mappings between input and required variable. They introduce non-linear properties to our neural network. They convert an input of an artificial neuron to output. That output signal now is used as input to the next layer. Perceptron was introduced by Frank Rosenblatt all the way back in 1957. It's an algorithm for supervised learning for binary classifiers. And this algorithm enables neurons to learn and process elements in the training set one at a time. The picture is a recap. We have seen inputs, weights, net input function, activation function, and output. There are two types of perceptron, single layer and multi-layer. Single layer perceptron can only learn linearly separable patterns. Multi-layer perceptrons or feed-forward neural networks with two or more layers have a great processing power. So let's go through it. The feed-forward neural network, it means data flows in only one direction, forward direction. The main agenda is to minimize the error, and for that there are various methods. In feed-forward neural network, when the input is given to the network before going to the next phase process, it guesses the output by judging the input value. So guess equal to input times weight, and error is desired output minus guess. So the input features are then multiplied with these weights to determine if the neuron fires or not. The perceptron receives multiple input signals, and if the sum of the input signals exceeds a certain threshold, output a signal. So how does the perceptron function looks like? The perceptron is a function that maps the input x, which is multiplied with the learned weight, and output is generated. So f of x is 1 if wx plus b greater than 0, where b is a bias, an element that adjusts the boundary away from origin, and w is a weight. Now if there are m inputs to the perceptron, it is sigma I equal to 1 to m wixi. Activations functions can be of multiple types. It itself can be a video by itself. So we are just showing here some examples: the step function, the sine function, and the sigmoid function. So a decision function of perceptron is defined to make a linear combination of x and w. So w equal to w1 all the way to wm, x equal to x1 all the way to xm. The value z is a decision function which is sigma wixi. And if z is greater than 0, if z is greater than 0, the sigmoid function, the decision returns 1, otherwise minus 1. So bias unit, for simplicity, the threshold theta can be thought to be left and represented as w0 x0, with w0 and x0 being 0. So the w0 is called as bias unit. So with all these, the output here looks like, since we set 1 and 0 minus 1, the output function will look like this. So we categorize the input data into either plus or minus. How does perceptron algorithm looks like? So it looks like this. You first initialize your bias, and for each training sample predict y prime, and then if yi not equal to y prime, update your weights, return final weight factor. If there is a mistake happen, we will update the weight function, otherwise we will continue. So r is the learning rate here, the r here, a small positive number, and it is a mistake driven algorithm. As I said, a mistake either happened as positive or negative, we will learn from it. And this is simplest version. We will see more robust versions maybe later. So with that, let me thank you. This was intended to give you a high level introduction to perceptrons, and hope you are clear about it. Thank you very much for watching my videos. Feel free to share, subscribe, give your comments, feedback. Thank you. Bye.